Greetings, respected judges. We are Team 1018 from Chamla College, University of Delhi, India. Our team members are Vinit, Kumar, Singh, Swapnil Singh, and I'm Tanishka Sharma. We'll be discussing Problem B and AI Ouroboros. Our coach is Dr. Rajni Arora. The term Ouroboros comes from an ancient symbol depicting a serpent eating its own tail, representing a self-sustaining yet self-consuming cycle. In our model, this symbol perfectly captures what happens when artificial intelligence begins training on its own outputs, creating a recursive feedback loop that degrades knowledge quality. Now, to begin with, Vinit will give you an overview of our presentation structure.
Thank you, Tanishka. Our presentation is divided into eight key parts. Analysis of the reference paper, our model assumption, the system of equations, the three cases studies in the problem, which is monoculture collapse, human in the loop, and the Weber effect, with the conclusion and strength, weakness, and future work. Let's begin with the analysis of the given paper. Over to Tanishka.
Thank you, Vinit. The foundation of our work is based on the paper by Ilya Shumarlov et al., which highlights a critical phenomena known as modern collapse. Modern collapse occurs when newer AI models are trained on data generated by previous AI rather than authentic human-created data. You can think of it as making a photocopy of a photocopy. The first copy looks fine, but each new one loses a bit of quality. After many generations, the details are gone and the result is unreadable. Similarly, when AI keeps learning from its own output, the clarity and diversity of information degrade over time. To explore this mathematically, we developed a simplified but powerful model. Swapnil will now explain the core assumptions.
Thank you, Tanishka. Now, to study this model mathematically, we model the entire public data to pool as two content types. First one is H of T, which is high quality human-like content. Second one is A of T, which is low quality, that means AI generated content. And we introduce five key parameters. The first one is P, which means R, rate of new human content. G, rate of AI generated content. E. Rate at which human edits or fix AI content. D. Model diversity factor. I would like to change the slide. D varies from 1 to 0, 0 to 1, which means 0 means high diversity and 1 means monoculture. And the next one is delta, decay rate, taken as a constant 0.25. Now, next one is K, collapse exponent. This exponent is controlled by model diversity slider D, which is K equals 2.0 minus D. If D is equals to 0, K equals to 2, the new quality will be Q square. This causes collapse. If D equals to max, which is max diversity, K equals to 1. This new quality will be Q raised to power 1, which is Q. The AI just photocopies the quality and no collapse occurs. Now I would like to define the quality of new AI content, which I have denoted by Q new. The quality of new piece of content the AI generates is the quality of current quality, which I have denoted by Qt, is raised to the power of the collapse of exponent k, which I have represented in the form of equation. The AI generates G dot q new of new good content and G dot 1 minus q new of new bad content. Now I would like to move our next slide, which is our model's equation. We then express the change in these content pools with two differential equations. In short, they describe how human and AI content evolve over time, including how much delay, how much is rescued, and how much new bad data gets collected. The key interaction term here is A divided by H plus A, which shows the fraction of bad data in the pool. The more bad data we have, the more likely is that the future of AI content will also be a low quality.
Case 1 is the monoculture collapse. We simulate a world where humans produce very little and AI dominates. P equals to 1. E equals to 0, G equals to 20, D equals to 0. The result is catastrophic collapse of quality. HT declined sharply and ET inclined sharply. Without human oversight or diversity, the system self-destruct, the true AI Ouroboros. Swapnil will now show how human feedback changed this.
Thank you, Tanishka. Now I will discuss case 2, which is the human in the loop. Now, human actively use AI content and edit it, where E equals to zero point 0.5. The system stabilizes to its non-zero equilibrium. Even minimal human intervention can maintain long-term sustainability. Now I would like Vinit to present the third case, which is Babel effect.
In this case, no human editing, but high AI diversity results collapsing is prevented. Diversity breaks the recursive feedback loop. Multiple AI with distinct architecture keep the ecosystem stable. We call this the Babel effect. Tanishka will summarize our findings.
From our analysis, we derived three conclusions. The first one is that quality collapse occurs when AI becomes a monoculture and human engagement declines. Model diversity plays a vital role in preventing recursive degradation, and a stable equilibrium can be achieved when either human editing or diversity exists within the ecosystem. Therefore, the future of sustainable AI depends on human-AI collaboration and plurality of models rather than domination by one. Our model's strength lies in its clarity and simplicity. It captures the essence of how AI content quality evolves using only a few interpretable parameters. However, one limitation is that we treated quality as a single valued parameter, while in reality quality is multidimensional. For future development, we aim to model HT and AT as quality distributions instead of average, extend the system into a network model where diverse AIs train on distinct data subsets and explore scenarios where the decay rate delta varies dynamically over time. These refinements will bring the model closer to real-world conditions and allow more accurate predictions of long-term AI evolution. To conclude, a mathematical model of AI Ouroboros shows that without human and algorithmic diversity, AI systems risk consuming and degrading their own knowledge base, but with collaboration and variation, the system can sustain itself indefinitely. Thank you for your attention. We hope our work highlights